Today we're going to talk about section 4.3, which basically deals with complex zeros and the fundamental theorem of algebra. You already know that the degree of the polynomial determines how many solutions there are. Well, a polynomial can have real zeros and it can have imaginary zeros. You learned about imaginary numbers in Algebra 2. The thing about imaginary numbers is that imaginary numbers travel in pairs. So if you have an imaginary number of I, there's also going to be a negative I. If there's a 1 plus 2i, there's also going to be a 1 minus 2i. So let's look and see how this all takes into play. So every polynomial, first, we need to know, can be written as a product of linear factors. So if we have this polynomial here, we can either factor it or we can grab our calculator and find out what our solutions are to write our factors. So grab your calculator, and in our y equals, we're going to plug in 2x to the third minus 18x. And then again, you can either look at your table or you can look at your graph to find your zeros, and we can see our three zeros here. We have one at -3, at 0, and at +3. So to write our factors, so if our zeros are at 0, 3, and -3, we write our factors, y equals x minus 3, x plus 3, and an x. And those can be in any order. Any order. Okay. As I stated earlier, imaginary zeros will always occur in pairs. So, as I stated, if 3i is a 0, then -3i must be a 0. If 2 plus I is a 0, so is 2 minus I. So we're going to be given zeros and write our polynomial function in standard form, which we already did earlier. So let's review that. It has a zeros at 4 and -7. So we're going to write x minus 4 and x plus 7. Remember, our factors are the opposite sign of our zeros. And then we multiply. X squared plus 7x minus 4x minus 28. So x squared plus 3x minus 28, combining like terms, and we have our polynomial function. So we already know how to do that. So let's add in imaginary numbers. So we have 2i and -2i and 3. So we're going to write x plus 2i and x minus 2i to accommodate for our imaginary numbers and x minus 3. So what happens when we multiply imaginary numbers? Let's refresh our memory. We still have x times x to give us x squared. We have x times -2i, which gives us -2ix, and 2i times x give us positive 2ix. And then we have 2i times 2i is minus 4i squared. So that's the same thing as what we did up here. If you notice, when we have a positive and a negative, our middle terms go away, and we just have x squared minus 4i squared. If you recall, I squared is the same thing as -1. So I have a -4 times a -1, so I'd end up with an x squared plus 4. So you can multiply it out, or you can remember when I multiply 2i times 2i, 2 times 2 is 4. Since there's i's, one's positive and one's negative, I'm going to end up, it's going to cancel the negatives and turn it into a positive. I'm then going to take that times x minus 3, and I get x cubed minus 3x squared plus 4x minus 12 as my final answer. Okay. So the last one we want to talk about is just a little bit harder because I have -1 plus 2i. So I know since I have -1 plus 2i, I also have -1 minus 2i because imaginary numbers travel in pairs. And I have a 0. So let's first write it in factored form. We know this one, that's easy. We're going to write x minus 5. So how do I write these? We always look at the number part, -1. Just like we had 5, -5, we have -1, we're going to have x plus 1. So I'm going to write that for both of them. So I have x plus 1 plus 2i and x plus 1 minus 2i. Now I wrote it this way because it's a lot easier to multiply if you think of this as a binomial times a binomial. So here it is in factored form. I'm going to write it in standard form, and I'm going to multiply the two hard ones first. Again, we're going to take this times this. That's my first times my first. So we have x squared plus 1x and 1x is 2x plus 1. And then when we take this times this, we get negative, and this times this, we get positive. So you can see our middle terms go away. So we don't even have to worry about multiplying them. We just need to multiply our binomials, and then we multiply 2i times negative 2i, which we learned up there is plus 4. So we can combine these together to give you 5. So you end up having x squared plus 2x plus 5 times x minus 5. And we're going to multiply that all together. X times x squared is x cubed. X times 2x is plus 2x squared. X times 5 is plus 5x. Minus 5x squared minus 10x minus 25. Okay? And then we simplify. X cubed, 2x squared, and then minus 5x squared is minus 3x squared. A 5x and a minus 10x is minus 5x. And then we have minus 25 to give us our final answer. So that stops part 1.